So up next, so we are a bit running out of time. So up next, we have Karin Landers, Senior Marketing Manager at Ververica, presenting KartShoppe, real-time feature engineering with Ververica and Apache Flink. Please join me in welcoming Karin Landers to the stage with a round of applause.
Hi, everybody. Thank you for joining. All right. So today we're going to follow the journey of a fictional e-commerce company. I'm going to call them KartShoppe, and they're not so loosely based on real friends and partners that we have, for example, Alibaba. So KartShoppe is kind of an interesting e-commerce in that they operate as a popular online marketplace that collects a lot of data points. So every click, every user view, every purchase that happens is creating incredibly valuable data for them. And that user behavior is actually the thing that they're most interested in being able to track based on what those clicks happen to be. And arguably the thing that's most valuable for them is actually that user data. So the team has a lot of use cases that they're trying to solve with that data. They're trying to figure out an awful lot about things like providing a meaningful customer experience. They want to be able to create a recommendation engine that works in real time with them. They're also really interested in how they can create a fraud detection engine that also reduces their latency and is able to respond in milliseconds when someone logs in or when they're trying to check out through their cart itself. They also want their dispute center to be able to work well, their customer service to be able to work well, and also their logistics to keep up in real time also. So the entire point with KartShoppe is right now they'd very much like to be able to make their online storefront something that is incredibly easy for the customer to experience and use. But they've got a major challenge that's been happening. And that challenge that they've got is that they simply aren't entirely sure if across the use cases that they're using here also, they're not entirely sure what's happening, but they're not keeping up with what their users are actually trying to do. So the feeling that they have that's kind of unshakable is that their data pipeline and their user experience aren't aligning. There's too much of a lag between the two. So their significant challenge for the data teams is simply that they're trying to keep up with how they can utilize the data that they've got in place and then make sure that they're creating that seamless user experience also. And there's a lot that goes into why these challenges exist, right? For example, we have digital native users. This has changed a lot over the past 10 years. Everything is online. Everything has massively increased in terms of what the potential attack vectors are when they're trying to set up this fraud detection engine also. Our little mobile phones, which we are clearly addicted to, and our short attention spans have also created a mobile-first experience where the small screens and the shorter attention spans means it's easier for them to then cross over into where there may be potential issues with changing where it is that they're doing their shopping. In addition, there's a lot of competition out there for this space, so being able to keep these things together becomes incredibly important for them. And there's a lot in terms of that that's contributing for the issues that they're having. And the explanation that they came up with pretty fast before Ververica got involved is that the time that their models are actually receiving the data is too far of a lag behind what that experience is actually happening for the user themselves. So this is incredibly hard when it comes to what they need to do for their recommendation and fraud detection agencies and engines to be able to further that customer experience. So the next step is this. They need to create feature engineering that matches and allows the team to be able to transform, create, and work with the relevant input variables that they have from the data that they're collecting to quite literally allow them to keep up with the users themselves. So feature engineering is going to become the crucial point where they ended up getting Ververica involved also in order to create that AI and ML pipeline that then ensures that the models are getting the most up-to-date information as fast as possible at the millisecond level for these use cases in particular. Because honestly, we would never really know how many people are going to be coming to a site as well as what might be happening if how many folks are coming to a site as well as how many people we can expect to actually be making a purchase at any given time. And any downtime is simply not something that's acceptable for them. So we're going to take kind of a high-level look at real-time data pipelines as a whole from this point, and then take a look at how their feature engineering was actually implemented and how we brought them into being able to keep up with that user experience in a more meaningful way. So with that, it's not just simply about stuffing as much data into an AI model as fast as you can and going as fast as you can with that. It needs to be a little more nuanced than that, right? So the point here is that we need to place in an end-to-end data pipeline that really continuously does the ingestion, the processing, the pre-processing and cleaning up, and really refines down the data. At the same time, being able to adapt and incorporate all the new information that's coming in also on its own, preferably, what we heard from in some of the keynotes this morning around agentic AI also. And the idea here is not just simply putting more data into it, but getting outcomes from that data that's actually more right. So let's take a look at the high level and talk about how KartShoppe or really any other business can implement a really effective real-time AI data pipeline with the support of feature engineering in place. So step one of building this, data ingestion, right? Real-time data ingestion begins at that ingestion point, and it captures the event and the data points from various sources. It doesn't matter what that source is, right? That can be APIs, third-party APIs. It can be any sort of integration across your databases, your message queues, things of that nature. Techniques like Flink change data capture come into play here, specifically because they can turn those databases into the continuously updated streams of inserts, updates, and deletes, so we can really see and timestamp and watermark what's happening in that. And Flink CDC is actually going to be tracking and identifying every single modification that's happened to the data when it's happened to the data, so that your data remains very consistent. And it also enables the models further down the road to get a clean and consistent view also, because having the freshest data possible is just as important as having any data possible. Step two, our data processing. Pre-processing is important. We heard it this morning, quality data in, quality data out. At this point, what we're actually taking a look at is before any of our models can extract any real value from themselves, our data needs to be clean, duplicates need to be removed, all of that basic information needs to be complete first. And completing these steps way early in the actual building of your pipeline is important because that allows the outputs that are going to be happening to be clean. Otherwise, we end up with a really compounding issue over time that impact the models also. Third step, feature engineering. This is where things get fun, right? Once data is clean, once the pipeline has actually been created out, that's when we can start turning that data into relevant features. And that includes the metrics, the attributes, everything that we need that captures the essence of what it is that you actually want your model to learn and grow from. So for example, KartShoppe might track something like the number of views that have happened over the last 10 minutes or the time since the user's last login, because those are features that help them then power their real-time recommendation engine. High-quality features as a whole are going to fine-tune and allow a model's view of user behavior to be cleaner. It's also going to boost the accuracy of that, and it's also going to dramatically improve its predictive performance later on down the line. Okay? And this step can really be thought of as being kind of the creative core for AI itself, because well-crafted features are what actually allow the predictive performance to improve. And we really want our developers and our engineers to be spending time on this part of building a data pipeline instead of on the point before that or after that when it comes to kind of building the architecture infrastructure for it. Next step, model serving and inference. So once we've got features generated and we're producing those and readily available, the pipeline then needs to be making sure that those features are deployed to the models on time and at scale, including demands that need to take place within the millisecond level. Okay? And then next we come into adaptive learning. Okay? Over time, the environment in which these models are actually operating are absolutely going to change. Conditions change all the time, data changes all the time. Adaptive or online learning is actually going to allow these models to then go ahead and update their parameters without the need for downtime and complete retraining, both things that are too expensive when we're trying to do millisecond level use cases. So this capability is super important for situations like evolving fraud techniques or changing customer preferences, because by getting the latest data in, our models are going to then increase their relevance and their effectiveness also. And every shift in real-world behavior will have a shift then in the model also. And then finally, our feedback loops. While adaptive learning is actually focusing on the real-time changes that are happening inside the data itself, Feedback loops emphasize the ongoing continuation of the training of the model itself and the model performance, because every prediction is going to end up creating some sort of an outcome. We know this. For example, whether a recommended item is actually clicked on and used or placed in a cart is going to immediately impact and create new content also. And then also if fraud detection goes through, whether something was actually identified as being fraudulent is of course going to have an outcome that's affected to it also. And these pipeline records allow the model to then start training itself, again, removing that downtime. And this continuous feedback, these continuous mechanisms that are happening then underpin when our AI models and our machine learning has really met a certain amount of maturity, right? The system is not only able to identify new patterns of behavior and data, it's also able to extrapolate what happened when it succeeded and what happened when it made a mistake from prior decision making over time. So, yeah, it's super easy to make a continuous, clean, precise data platform, yes? So KartShoppe recognized right about here that getting their data pipeline up to date and clean and implementing feature engineering absolutely had to be priority number one for them. Particularly so they could get rid of that weird feeling that they weren't keeping up with what was actually happening to their users. Now, KartShoppe, when we first met them, was still heavily relying on batch processing. And that setup where the engineers were creating features, they were generally on very outdated data sets. It could be a couple of hours. Some of them were actually up to months. And while lots of use cases still really benefit from batch processing, and there's a place and time for it, what they were trying to accomplish with their use cases really demanded that real-time data also, and to move all of that faster, and batch processing just can't keep up with those. So for example, for the recommendation engine, it's really interesting to know what a user was doing last month, but it's way more powerful to know what they did just a couple of seconds ago and be able to act on that in real time. So how do we go about turning raw real-time data into high-quality features and into better AI models? For companies like KartShoppe, this is where implementing a streaming data platform and using those resources becomes really important, because it makes the process much more seamless for the engineers and much less expensive for them as well in terms of time and effort. You've seen a slide a little bit like this in the keynote this morning, yes? An important one. Again, the closer we are to the timeline, the faster we are and the better we're able to make smarter decisions with that. The longer we stretch that out, the less meaningful those decisions become over time. So this is where Ververica stepped in. We offer a unified streaming data platform, and we're able to then connect and allow for businesses to be able to spin up these platforms and be able to solve these use cases and spend the time in the feature engineering doing the thing that actually helps set up these rule sets better for them. We're handling the ingestion, we're handling the cleanup, the pre-processing, making sure that your source and your sink makes sense for what you're trying to solve on this. And that allows for you to then spending a lot more time on the really fun part of building out those feature engineering bits. And although we can absolutely help with that too. So remember again, a predictive model is really only as good as the data that we're actually putting into it. So this is where feature engineering becomes the thing we really want to start focusing on, and where KartShoppe wanted to spend their time. So something that we know, features aren't static, right? KartShoppe data is dynamic, it's changing constantly. Static, pre-computed data just doesn't cut it anymore. It leads to stale models, it leads to degraded output and performance. This is particularly bad in situations where the applications need decisions to be made in real time, like fraud detection and recommendation. Now, feature engineering transforms this raw data into something that's much more meaningful, because it's allowing the improvement of the models also over time. So we want our AI and ML models to understand and process our data, but we also want features that in step are able to translate that data into something that's actually more meaningful for them. So great features are going to create a couple of different things. They're going to give us actionable signals, right? They're not simply trying to replicate the raw data. They're actually trying to dig in and highlight what's most applicable from the data within that and be able to identify the patterns that are in that more easily. Kind of needle in a haystack, if you're familiar with that idea. Find the stuff that's really important inside all of the noise of the data that might not be so important. We also want to improve our model accuracy, right? When features are designed to help capture the most relevant data, That allows your user behavior to be acknowledged and used in real time also. And robust features are going to help the model also to be able to generalize more effectively over time as well, especially when it's presented with new data sometime in the future point. Better generalization translates into better predictions and better overall model performance and a more consistent performance from it. We also want to reduce complexity. Great feature engineering can include that also. It's simplifying out the model views and how it views the data, right? So instead of having the potential where there's so much noise that the model doesn't know what's important anymore, or it starts to try to make correlations between data points that really shouldn't be correlated, feature engineering helps to streamline that and transform that so that it's easier for it to identify what is important to start making decisions with. And domain relevance. Okay? Feature engineering often integrates domain expertise. This means that every single action needs to be tied to an actual user activity or performance, right? So we can use things like average purchase frequency. We can combine that with time since last login, and we start to gain a much better understanding of what a user's behavior is and what it is they're trying to do over time also. So here we've got some time-based joins for event correlation. This is where we can take multiple streams, combine them together, and then come out with a much more interesting output from it too. And we can do this across a lot of different stuff. So for example, if we have our time-specific time to purchase and then our product views to purchases, we can join these together and actually come up with something that's watermarked and stamped so that we're making sure that the order is happening appropriately for these as well. And we can do this for a lot of different great questions. This is one that we put up for KartShoppe also. But it's a way to correlate this data that you would need to do on time and in order to get a complete view for it. Now, something that's really interesting too is building a feature store. KartShoppe recognized early on they needed a place that was kind of that brain that could correlate as a dictionary where all of their features were actually at. So this is very interesting because you heard about Flus earlier this morning also, and this is something where Flus can really help with actually creating this feature store. But here we have our data ingestion coming through. Ververica is able to take that raw data. We can then throw it through stateful queries, time-based joins, and the windowed aggregations, be able to place all of those rule sets into a feature store that then the rest of the business is also able to incorporate and utilize also, kind of like a Wikipedia, if you will, for your features that are available. And then send that back the other direction as well. Let's take a look at the reference architecture for the recommendation engines also. So this is a pretty high-level one of how KartShoppe put this together. They have their mobile app, their website, and their inventory. We're tying that in also. That's an important one for some of these use cases. Pushing it through Ververica's unified streaming data platform where a whole bunch of fun stuff is happening besides just the ingestion and the processing of it. We've got complex event processing that we can base in that. They're using the feature store, tracking all of the user activity. In addition, we're not just using the real-time data that's coming through. We're also able to pull from the reference and historical. So your data lakes, again, Paimon and Flus start to come into effect here also in pulling in that historical data and decisions and helping place that model inference together. And then our outcomes end up being our much more timely personalized offers. We can do inventory management with this. This was kind of a tertiary version of their use case that they were looking at. We can also pull the recommendation database and then start giving them better recommendations and personalized offers in time and on time also. Okay, so I'd like to take you through a quick pre-recorded demo of the recommendation engine, how this is working within Ververica's unified streaming data platform. So I'll kind of talk through this while it plays. So first, welcome into the platform itself and into the cloud view. We're going to go ahead and set up a deployment. Once we hit that deployment, we'll allow it to run. We'll create. And this is all the interface and UI that's fun to work with. We're going to go for Python for this one. Here we can start setting the parameters. You can see how quick it is to be able to set up these jobs in a more meaningful way. Name our deployment. We'll call this e-commerce or recommendation engine. I'm not sure what we put in there. Connect it over to our Python. Backend view. Run this. And then it gets fun. We can start setting times. I think I had this running in double speed when I first recorded this, and it didn't make it onto the stack. All right, so we've got our deployment in. Now we're going to go back into it real quickly. And there's a reason for that, because we want to go into autopilot and actually set what our threshold is for the amount of time that we want this to be running at. So we're going to go ahead and pull that up to start. We can go with initial mode, we can go with resume mode, but we're actually trying to get in again to set that speed. So we want to do a configuration of the autopilot here. We don't have a threshold for a recommendation engine to have this go slowly. We need this to be moving as close to real time as we can. So we're going to dump down and take a look at our adaptive strategy. Then we're going to go ahead and update our max delay. So here, that won't do. Let's put it on seconds, max 1 second. And as fast, slow as we are when I was clicking through, this is as fast and slow as the setup would actually be happening at. So here we go. We've got this starting. Now we're going to go over and actually take a look at what this looks like from a user perspective. So I'd recommend paying most attention up here to what the recommendations are that are coming up and how they change. So as we hover or add things into our cart, this is going to start immediately doing updates in as fast or real time as we can with it as well. So for example, we were looking at the earphones, so now we get, okay, do you need a base for that headphone set? Would it be meaningful for you to have a carrying case? Then we go over and take a look at, resolution's great on here. Here we go. We take a look at a physical book. Okay, well then the recommendations are gonna start changing. And this is real, I didn't edit this part. This is as fast as this is happening. So, okay, we looked at a book. Do you need a reading light? Do you wanna write your own book? You can have a notebook for that. Then we jump into, okay, I'm looking at the laptop. Would it be helpful for you to have a bag or a mouse or any of this other stuff? You get the point. These kind of recommendation engines that can move in this real time is pretty powerful stuff. Okay? All right, we'll get a few more moments. And it's fun. It's fun to just see what we can change it to. I didn't hover over coffee. I meant to do that. I was really interested what it would come up with. But here's our back end of what's happening underneath the hood as this is processing through. So user experience, how we set up that deployment, and then what it looks like from here. Okay, I think we can click on to the next one. Now here's the thing. This is all going to look the same regardless of what the use case is. When you're implementing in that unified streaming data platform, regardless of source and sink, everything that's happening in the middle is just that configuration that's happening. So here, for example, for their fraud detection engine, a very similar, different use case, different user experience, but the same process of sorts is happening on the back end. Our request comes through, whether that's coming from a payment, a click, the mobile app, the checkout, or customer care team might be involved in something. Again, we're pushing it through our unified streaming data platform, doing all of the portions of the ingestion, adding all of the transformation that's happening in that. We are able to, again, pull from those data lakes because, again, data is really interesting in that it's not just what's happening right now. Sometimes what happened in the past can be something just as important, and if you can pull that into the real-time stream at a very low latency and incorporate that in, you might end up with a much better outcome and input of what's actually happening, and what the machine would then be able to know and tell from it. And then again, within milliseconds, we get our yes, you're approved, no, you're denied, or we could add in a third option in there. We're not really sure. Let's go ahead and have you verify in a couple different ways, okay? Okay, so the unified streaming data platform really does enable the real-time intelligence for AI across the whole, and we'll have a couple more resources that'll be available on here, but that feature engineering is where we wanted KartShoppe to spend their time, where they want to put the joins, what they need their source and sync to be, how they can actually pull this into real-time engine also. And then here's where it gets kind of interesting, and we can take a little bit of a look at what it means when we start having this work with agentic AI, because that is where we're going with this as well. So e-commerce platform, again, any of these customer activities can happen or more. We get data points from that, push it in through the engine. Our agentic workflows are going to be able to take a look at that adaptation of all of the different workflows that we have in place, number of views, our average purchase history, total amount spent, what's trending? I mean, that's a really important and interesting one to be able to make recommendations because we never really know. It might not be what that person's activity is, but it might be what's happening in the world as a whole at the time. And then we're able to come out with that high quality recommendation engine, and the model can keep feeding and telling itself and allowing itself to learn as it goes as well. And all of this, again, very important, sitting at the millisecond level. Also, another way down the list of things that they wanted to do, and then they had enough time to do it, is the distribution and logistics, right? Speaking of time. So here, their online purchase goes through. One of their last use cases, which they had time to implement during this project because of the setup, allows for them to be able to pull in a user experience that allows them to click in, make that purchase, and then be able to get that package delivered with all of this great information on the inside happening. We can take into correlation the best route for it, what tariffs it might be responsible to, what customs, addresses. How meaningful is it if your customer and KartShoppe's customer can get a text saying, hey, your package is on the way, expect delivery at this time, at this date. That becomes a better user experience. It also keeps KartShoppe front of mind for them so that they come back to the site when they have additional purchases that they might consider making. So in conclusion, KartShoppe, again, made up name for a real company use case and company that we help with that doesn't necessarily want to be on the big screen right now, now has access to these things, recommendation engine, the ability to do their fraud protection through this workflow as well, the ability to do logistics. And they have a litany of other ones that they're looking at also. Those were just kind of the top tier that they were looking through. A couple of final resources for everybody. If you're interested in learning more about the Unified Streaming Data Platform, that's the QR code to go to. If you're interested in learning about the engine that powers that, the Vera engine, this is 100% compatible with Apache Flink. We're the original creators of Apache Flink. We're sitting right there with it. We are still a major part of the community and adore and are absolutely here for that reason. But do come and learn more about Vera, which is the engine that Ververica uses for that. It's about 2x faster than Flink. So that's kind of an interesting one. And also, we can help pull and set up that operational, because face it, Flink can be hard. We do have a blog on KartShoppe that's out, so if you wanted to read the whole blog, some of it will look very familiar, but actually the last half of it or so, there's some more information about the different types of joins that we were doing and how that's feeding into their use case also. I mentioned Floos with building a feature store. I would absolutely take a look at this webinar. Jark, who we met or saw this morning, and then also Giannis, who is my colleague and good friend, put this webinar together about, and part of it does hit on building a feature store utilizing Floos, so it's a pretty interesting one. And then also, I can't say enough good things about this event. If you enjoyed your time here, you should also join us. We are going to be in Barcelona, October 13th through 16th. I think we're at time, so yes. Thank you, everybody. Appreciate it. If you have questions, Ververica does have a booth downstairs. We'll be down there, so please do come and ask.
Thank you, Karin. Thank you. Yeah, we will have a breakout now for a few. Yeah, we will have a quick 15 minutes coffee break. So feel free to enjoy some of the refreshments and take this opportunity to network with people. And we will come back in 3:45. It's a very nice call.